Imagine looking up at the night sky and discovering that the moon is gone. No pale light, no familiar crescent, and no glowing full moon above the horizon. At first, the sky would simply appear darker. But the disappearance of the moon would gradually change oceans, animals, climate, and even the long-term stability of our planet. Of course, the moon cannot simply vanish according to the known laws of physics. For this thought experiment, we will assume that it disappears instantly, without exploding, leaving debris or releasing destructive energy. One common misconception is that Earth would immediately leave its orbit around the Sun. That would not happen, because the Sun's gravity is what keeps Earth traveling through the solar system. Earth and the Moon currently orbit around a shared center of gravity. If the Moon disappeared, Earth's motion would change slightly, but our planet would continue its journey around the Sun. The first obvious difference would appear during the night. Without moonlight, nights outside cities would become much darker than most people have ever experienced. The stars in the Milky Way would become easier to see. But landscapes, forests, and oceans that were once illuminated by the moon would disappear into almost complete darkness. There would never again be a lunar eclipse. Solar eclipses would also vanish, because there would be no moon passing between Earth and the Sun. One of the greatest changes would take place in the oceans. The moon's gravity is the main force responsible for the regular rise and fall of ocean tides. As Earth rotates, the moon's gravity creates enormous tidal bulges in the oceans. Coastlines around the world experience these movements as high tide and low tide. If the moon suddenly disappeared, the existing tidal system would begin to reorganize. The oceans would not remain completely still, and there would not necessarily be one enormous global tsunami. Water that had been shaped by lunar gravity would redistribute itself. This could create unusual currents, waves, and temporary flooding in some coastal regions. Tides would not disappear entirely. The Sun also pulls on Earth's oceans and would continue to create solar tides, but these would generally be weaker than the tides we know today. Many coastal environments depend on the constant movement of water. Mudflats, salt marshes, mangrove forests, and tidal pools are regularly flooded and exposed by the moon-driven rhythm of the oceans. Without strong lunar tides, these habitats would change dramatically. Some species would lose feeding areas, breeding grounds, or protection from predators. The effects would extend far beyond the coastline. Tides help mix nutrients and oxygen through parts of the ocean, supporting complex marine food chains. Many animals have also evolved around the lunar cycle. Corals, fish, crabs, insects, and other creatures use moonlight or phases of the moon to coordinate feeding, migration, and reproduction. Nocturnal hunters would lose an important source of natural light. Their prey would also experience completely different conditions, changing the balance between predator and prey. Sea turtles and other animals can use natural light from the horizon when navigating near beaches. A permanently moonless sky could make this behavior more difficult, especially in areas already affected by artificial lighting. The disappearance of the moon would therefore cause widespread ecological disruption. Some species would adapt, but others could decline because their biological rhythms developed over millions of years. Human life would also feel different. For thousands of years, people have used the moon to measure time, plan agriculture, navigate, and create calendars. Even the concept of a month is closely connected to the moon's cycle. Religions, festivals, myths, and traditions across the world would lose one of their most important celestial symbols. However, the most serious consequences might take much longer to appear. The moon acts as a stabilizing influence on Earth's rotational axis. Earth is tilted by about 23.5 degrees. This tilt creates the seasons as different parts of the planet receive changing amounts of sunlight throughout the year. The moon does not hold Earth's axis perfectly still. but its gravity helps limit extreme variations. Without it, the gravitational influence of other planets could cause Earth's tilt to change much more dramatically over millions of years. The planet would not suddenly fall over or enter an instant ice age. But over geological timescales, larger changes in axial tilt could become possible. If Earth's tilt increased significantly, seasonal differences could become much more extreme. Some regions might experience hotter summers, colder winters, and major changes in rainfall. If the tilt became smaller, the seasons could weaken. Polar regions might receive less summer sunlight, allowing ice sheets to expand and altering global climate patterns. These changes would happen slowly, but they could transform where forests, deserts, and ice sheets exist. Entire ecosystems would have to migrate, adapt, or disappear. The moon also affects the speed of Earth's rotation. Tidal friction caused by the moon gradually slows our planet, making the length of the day increase by a tiny amount over time. If the moon vanished, Earth would not suddenly begin spinning faster. A day would still last approximately 24 hours, but the moon's long-term braking effect would largely disappear. The history of Earth might have been very different without this effect. Billions of years ago, our planet rotated much faster and days were considerably shorter. The moon has slowly taken rotational energy from Earth while moving farther away. Its influence helped shape the rhythm of days, oceans, and life throughout the planet's history. There is also evidence that the moon played an important role during Earth's early development. It probably formed after a massive collision between the young Earth and another planetary body. That event may have influenced Earth's composition, rotation, and internal structure. The moon that emerged from the debris became a permanent companion during the evolution of life. A moonless Earth would still remain a living planet in the immediate future. The atmosphere would not disappear, gravity would still hold us to the ground, and the sun would continue to rise. But the world would become darker, its oceans quieter, and many natural rhythms less predictable. Over very long periods, Earth's climate could become far less stable. The moon may appear distant and silent, but its influence reaches every ocean and every continent. It is not merely an object in the sky, but part of the system that made Earth the planet we know today. Its disappearance would remind us that even the most familiar objects in the universe can play an extraordinary role. Sometimes we only understand the importance of something when we imagine a world without it. What other cosmic event should we explore next? Subscribe to WunderAtlas World and join us as we uncover the mysteries of our planet, our history, and the universe around us. Until the next wonder.